Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is the Oracle Cloud Security Quick Start, which will cover key security features, best practices, as well as services such as identity access management. Now, I'd like to introduce Hannah Raksha and Brandon O'Leary as today's presenters. With that being said, I'll hand over to Hannah.
Thank you, Borna, and welcome everybody today. So as Borna mentioned, we're going to be going through the Oracle Cloud Security Quick Start. What we'll be covering today is based into two things. The first is security of the cloud. What this includes is the Oracle Cloud ecosystem, Oracle security principles, our shared responsibility model, compliance, defense in depth, and secure design. The second thing is security in the cloud. So this is our identity and access management, data protection, monitoring, detection, and prevention, and some workload-specific optionals. So by the end of this presentation, you should be able to describe the shared responsibility model and how it applies to your environment, explain OCI's identity and access management concepts and strategies, compare the security services available in OCI as well as their use cases, and learn how to implement the basics of setting up and configuring CloudGuard. So that first section, starting with security of the cloud. When we think about how to make security easier for our customers, we focus on 5 things: ease of use, transparent, prescriptive, automated, and unified. These 5 principles are what guide our design and development for our security principles. So starting with ease of use is our #1 priority. We know that we have to make people's lives consistently easier, and it's harder to add ease of use after you develop solutions to your problems. Second, Oracle Cloud provides customers with a transparent, always-on security posture with integrated controls. Secure shouldn't be a construction project. Third, prescriptive. We believe in providing preventative guardrails that help reduce the chance of human error. Everyone makes mistakes. It's what makes us human. So a safety net is almost always a good thing. Fourth, automation. So automation is a key theme across Oracle, and it's certainly true in the domain of security. We want to automate as many routine tasks as we can that enables people to spend time on their higher level issues. And then finally, unified. We have unified tools and controls that help make everything easier. Oracle Cloud Security tools are available within the integrated OCI console, and this ease of access and integration means that you only have to look one place for answers. So here we have our shared responsibility model. On the left chart here, or in the legend here, we have blue for the customer responsibility, and then green for the cloud service provider responsibility, in this instance, Oracle. So with your on-premises deployments, you can see everything here is in blue, which means it is entirely the customer's responsibility. As we get into our as-a-service models, this is where the cloud service provider starts to take on more responsibility. So for infrastructure as a service, we have the physical infrastructure, network, and virtualization layers. Platform as a service is going to add that guest OS, and then software as a service, the only customer responsibility are the user access and identities, as well as the data that is being put in. Now, building trust is important. This is how OCI has demonstrated its commitment to security, privacy, and compliance. The first is through external documentation. So we have Oracle security practices, cloud compliance, white papers on privacy practices, security, as well as security best practices. Next, we have alignment collateral. So this is any OCI and GDPR white papers or any implementation white papers, as well as India RBI, RDAI, and OCI white papers. And then third, we have compliance reports. So this is our SOC credentials as well as our ISO credentials. And then our final is customer audits. We have compliance reports that can be walked through, as well as a security questionnaire and audit documentation. We have an expansive list of independent assessments across both industries and regions. We operate under practices aligned with the ISO IEC 27002 Code of Practice, from which we have identified a comprehensive set of security controls that we apply to our business. These security controls and operations undergo external audits additionally. We've also pursued a broad suite of industry and government certifications, audits, and regulatory programs. You can find more about our compliance online at oracle.com. Defense in depth. These are a couple of ways that security is automatically built in, ranging from identity, data, compute, networking, monitoring and prevention, as well as internet and edge. So starting with identity as an example, some built-in security are role-based policies, compartments and tagging, and then the respective principals for instance and resources. Data, we have encryption at rest and in motion, data safe, managed vault, and more. Compute, we have our off-box networking, which we'll be discussing next. We also do certificates and hardware security modules. Networking, we have our virtual cloud network, private networks, fast connect, secure VPN. For monitoring and prevention, we have CloudGuard, security zones, and vulnerability scanning. And then internet and edge, we have DDoS protection, web application firewall protection, and more. So the secure design of our off-box network virtualization. So this is very central to OCI's design because it greatly reduces the risks from the hypervisor. So the hypervisor is the software that manages virtual devices in a cloud environment. It handles server as well as network virtualization. Now, in first-generation cloud offerings, if a successful attack compromises a virtual machine and subsequently a hypervisor, there are no barriers to prevent an attack attempt to modify the network. So let's say this box down here gets hacked. There's nothing preventing it from going here and then eventually going to these other VMs. Oracle does it different from first gen because it uses a custom designed smart NIC that isolates and virtualizes the network. So the smart NIC is isolated by hardware and software from the host, which prevents a compromised instance from compromising the network. Oracle maintains greater external control of host network functionality and can help prevent network traversal attacks. Moving into our next section, which is identity and access management. So this is secure access to enterprise applications for both cloud and on-premises deployments. Oracle Cloud Infrastructure Identity and Access Management provides a cloud-native identity and access service as an integral part of any hybrid or multi-cloud environments. With highly adaptive access policies and capabilities, it can support many different IP applications and services, and Oracle can help enable rapid onboarding of users as well as services to meet your evolving security objectives. So some of the benefits of this are cloud native identity as a service platforms. It can support multiple clouds as well as on-premises. You can integrate identity management into your custom applications. It'll use context and risk-aware business logic for any third-party integrations. It can provide on-demand scaling and capacity, can manage user and access entitlements. It includes advanced adaptive authentication services and a unified identity leveraging single sign-on. So IAM provides, again, an enterprise class set of IAM features that I'm going to go ahead and describe in the term of 4 buckets. We're going to start with inbound authentication and SSO. So this is how users are authenticated into the service. We offer numerous different methods, including inbound federation, so either from other identity providers using federation protocols like SAML or OpenID Connect, or in other consumer use cases, if you wanted to use socials like LinkedIn, Twitter, and other platforms. We also have native authentication, of course, with several options for multi-factor, including a mobile app with one-time passwords or a simple push to approve. We support common. And then another is adaptive security. This allows us to evaluate session context in real time, looking for specific factors such as, is this user's device trusted? What network or location are they coming from? What does their recent behavior look like? We can use that telemetry to then decide whether to allow or deny access, or to step up authentication to a stricter multi-factor authentication mechanism. The second bucket is identity store and lifecycle management. This is about getting user accounts into the service, managing their attributes, role and group permissions, assigning permissions, provisioning and deprovisioning accounts, automating the synchronization, and setting security policies. So of course you can manage users and entitlements directly in the console, but it's also common for customers to want to automate account provisioning, deprovisioning, and entitlement management. There are several ways to do that. We have a rather popular app catalog that have pre-configured for provisioning. We can automate account management from Active Directory using the AD bridge. You can also use Provisioning Bridge to manage accounts for virtually any enterprise apps that may be running on-prem, which have been used for several years with Oracle Identity Manager. So there's a good amount of collective knowledge out there on how to interact with various applications. Third, we have our outbound authentication and SSO. So after we know who the user is and what permissions they have, this is how we'll enable single sign-on to target applications. We, of course, support open standards and protocols like SAML and OpenID Connect, but standards-based federation leaves out a lot of applications. We have an app gateway that enables SSO to enterprise apps. It supports HTTP header-based authentication. For web apps that don't support either of those, we also offer password vaulting and form fill to simplify the user experience. And we have a Radius proxy that allows authentication for databases and VPN clients, as well as offer a Linux PAM module that supports SSO to Linux hosts that are running on OCI. And then finally, OCI, Infrastructure as a Service, and Platform as a Service, IAM policies. Oh, OCI IAM policies, apologies. This allows you to manage access to your OCI resources like networking, compute, storage, and analytics. By default, all permissions are denied, so an administrator must create policies to allow access where appropriate. OCI IAM provides a very simple policy syntax that's easy to read and understand, which we'll look into a bit later. So we have our compartments to build onto our security infrastructure. Compartment is a logical grouping of related resources that can be accessed only by groups that have been given their respective permissions. So adding on to the structure, we can see here we have our infrastructure admins, our shared service admin, and our IAM admins. Each of them would need access to their respective compartment in order to be able to use or even see the resources in there. So for example, in the infrastructure admin, they have access to the infrastructure compartment, which depending on their permissions, lets them view, manage, access, edit any of the infrastructure resources. Compartments follow a child-parent relationship. So if you have access to the root, for example, which is the oldest then you have access all the way down and through. If, for example, you only have access to the shared services, you cannot then also access any information services or other compartments like enterprise data. Common uses are access control boundaries, customer and isolation boundary. It can use cost tracking tags for cost boundary, as well as budget and quota boundaries. So jumping into the IAM policy syntax, let me go ahead and build this slide out. So this is how you assign any sort of access to either a resource or an instance. So it follows the syntax, allow domain group to verb, and then here we have our verbs inspect, read, use, and manage. As we go down, this allows more levels of access, with inspect just being able to essentially read the list of resources, and manage allowing permission to modify, change, etc. the resources. So allow domain group to verb, and then object family. So here, if you wanted all resources control, or if you only wanted like your network admin to only have virtual network access, this is where you could specify things like that. In compartment, so compartment or tenancy, compartment is best to keep those roles separated again. But for any sort of administrator, you can do it for the whole tenancy. And then where conditions. So this is an optional sort of end here, and it can help narrow down specifically what you want the policy to cover. For example, you can do where OCI region equals Phoenix 1, or where database resources have name XYZ. So this helps you tailor your policies to exactly what you want. For IAM authorization, so this defines specific privileges through policies, which we just talked about, and then we're going to attach them to compartments. So using the example on screen, so policy A, we're going to allow default domain group A to manage compute in compartment A. So that means group A here can manage the compute inside of compartment A. Policy B, allow default domain group B to inspect compute in compartment B. So this means that they can look into compartment B, but they're not able to manage it. So similarly, group B is not able to manage or inspect inside compartment A because, again, we have a, and then user group A would not be able to manage or inspect in compartment B because of the lack of policies. The next section, we're going to talk about data protection. So this is the administrative, physical, and technical security controls. So starting with data encryption. Data encryption is on by default, and it cannot be turned off. This is included with OCI secrets, block volumes, object storage buckets, file storage, database services like Autonomous and Exadata, and the encryption is using AES 256. Data in transit is encrypted with TLS 1.2 and Media Access Control Security, or MACsec, for point-to-point security on Ethernet links. So for things like API consoles, load balancer as a service, by default it uses TLS 1.2. For things like OCI regions and availability domains, it's encrypted through MACsec. And then our virtual cloud network, our VCN encryption, is currently in progress. Moving on to our key management, OCI Vault service. OCI Vault is a secure, resilient, fully managed service that lets you focus on your data encryption needs without worrying about time-consuming administrative tasks required to achieve high availability, such as hardware provisioning and software patching. Vault uses HSM that meets Federal Information Processing Standards 140-2 and then security level 3, security protection certificate to protect your keys. OCI Vault is Oracle's native Gen 2 cloud encryption service. So what this does, you control and manage the keys that protect your data. It is available. It is a highly available service with 99.9 SLAs and 99.99% SLOs. Again, it supports regulatory compliance, which we discussed. And then you can navigate integration with many OCI cloud services, such as Autonomous, Exadata, SAS, object storage, etc. And it can support symmetric and asymmetric encryption. Finally, we have DataSafe. The DataSafe is a fully integrated cloud service focused on the security of your data. It provides a complete and integrated set of features for protecting sensitive and regulated data in Oracle's database. So the features are security assessment, user assessment, data discovery, data masking, and activity auditing. So for security assessment, this assesses the security configuration and can help detect configuration drift. For user assessment, you can identify risky users and develop strategies that allow you to reduce your attack service. For activity auditing, you can monitor your database activity and alert on any high-risk operations. For data discovery, you can discover your sensitive data, including how much and what kinds of sensitive data reside in your database. And then finally, we have data masking. So you can remove risk from non-production databases by masking sensitive data with realistic loop test data. One thing for sure to note is in regards to data masking, it needs to be done on non-production because it cannot be undone. With that, I'm going to go ahead and hand it over to Brandon for the next section.
All right, thank you, Hannah. All right, you should all be able to see my screen. My name is Brandon O'Leary. I'm also a cloud engineer here at Oracle on the customer enablement team. And I'll be taking us through the second half, which is monitoring, detection, and prevention tools. And we'll have a demonstration at the end that covers CloudGuard. So starting off, what is CloudGuard? So CloudGuard is an OCI service that helps you monitor, identify, achieve, and maintain a strong security posture on Oracle Cloud. You can use the service to examine your OCI resources for security weaknesses related to configuration, and you can also do user assessments to analyze any user activity. Upon detection, CloudGuard will suggest, assist, or take corrective actions. And CloudGuard also ties into a lot of other services such as vulnerability scanning, certificates, and many others to identify problems with configuration, or, as an example with certificate service, if your certs are coming up on expiration, CloudGuard can actually go in and generate a problem for you so it can keep an eye on, upcoming expirations. So when we're working with CloudGuard, there's a few different concepts to familiarize yourself with. We have targets, and targets are going to set the scope of resources to be examined. So as an example, targets are going to be set on compartments. They can be set on a child compartment or the root level compartment. And as Hannah explained, these compartments are hierarchical. So you can see here, this topmost compartment here that's green has CloudGuard enabled, and then it's going to automatically be enabled for the child compartments as well within the tree. If you were to set up the root level compartment as a target, then CloudGuard would apply to everything within your tenancy. Next up, we have detectors, and detectors are the components that identify issues with resources or user actions, and then also alert when an issue is found. So there's detectors relating to, compute instances, relating to configuration issues, relating to object storage. Next up, we have problems, and problems are going to be generated from these detectors, and essentially they're notifications that a configuration or user activity is a potential security issue. Finally, we have responders, and responders provide notifications and corrective actions for many different security problems that may exist. So some of these responders are automated, and some of them will provide you recommendations on remediation activities that fall in line with Oracle's best practices. So we'll take a deeper look at this within the demonstration. But next up, I'll show a workflow on how CloudGuard operates. Right, so this scenario here is pertaining to public buckets within object storage. So this could pose a critical risk to your environment if you have a public bucket in object storage, because essentially that data within that bucket would be publicly accessible, right? So you always want to try to keep your buckets private when you're using object storage, unless you have like a particular need to have a public facing bucket. So in this scenario here, we have a public bucket, right? On the left-hand side, a user makes object storage bucket public. From there, we have CloudGuard enabled, and the configuration detector is going to kick on, and that's going to trigger and create a problem. And the problem says, the bucket is public with the severity level critical. So this is going to be tied to the actual bucket. You can click right on the problem and you can see the bucket. You can see the unique identifier tied to that object storage bucket, the OCID, and you can make appropriate changes. We have a responder recipe that kicks in, and it's also tied into OCI event service. So with OCI events, anytime a state changes within your OCI environment, you can invoke different things to happen. So you can fire off a notification. Let's say you want to be alerted, or you want your administrators to be alerted via notification to their email or maybe a Slack message, right? We have OCI notification service. You can also use this event to trigger code to run. So if you want to have something in the background happen programmatically, you can leverage OCI functions. So that's one option here. And then we have our CloudGuard operator who can go in and remediate the problem. So in this case, we have a responder, and the responder is automated, and offers a one-click remediation. So that responder can make the bucket visibility private. You would just click remediate, and then from there, CloudGuard would make that bucket visibility private. And then from there, the bucket would be changed to private, and that critical risk would be mitigated. But this example here just pertains to one particular use case, right? The public object storage bucket. But you can imagine, how this could be applicable to your environment, especially when you're operating at a large scale. There's many, many different problems that can be detected. So it just helps to keep an eye on any issues pertaining to configurations or user activity and then be notified, right? And CloudGuard offers that single pane of glass view when it comes to detecting problems. So we'll talk about a couple more services here, and then I'll jump into the demonstration and do a good job of outlining, CloudGuard, how to set it up, and we can take a look at some detectors as well. So the first service here that we'll take a look at, aside from CloudGuard, is security zones. So security zones provide preventative guardrails that can be set up on a compartment. So if you want to explicitly deny a user action from taking place, such as denying the attachment of an internet gateway in your virtual cloud network, you could put a security zone on that compartment, and you essentially could, set up that security zone policy to enforce that rule that you want to apply. So again, you attach these security zones to a compartment, and if any of the security zone policies are violated, then that operation would be denied. So if we take a look back at that public buckets and object storage example, right, you could have a security zone that forbids the creation of public buckets altogether. So if any of your users try to create a public bucket in that compartment that's tied to the security zone policy, you would receive an error message. Additionally, you can modify an existing, private bucket and make it public because the security zone would, give you an error message and deny that action from taking place. We also have this maximum security zone. So Oracle is going to provide you a list of policy rules called the maximum security zone. And then what you can do is you can go in and pick and choose the rules that you want to apply to your compartments. So you don't have to use all of the rules because it really locks it down. And a lot of them are, you may not need every single rule. So we give you that flexibility to go in and you can pick and choose the rules and then you can make custom security zones with that rule set and then apply those to the compartments where appropriate. All right, next up we have Web Application Firewall. So WAF is going to provide you with the ability to create and manage rules for internet threats, including cross-site scripting, SQL injection, and other OWASP-defined vulnerabilities. You can also set up access control rules and limit based upon geography or the signature of requests. So it's essentially our web application firewall and it operates at the layer 7 level. There's also rate limiting. So if you wanted layer 7 DOS protection on your load balancers, you could go in and set up rate limiting and define the amount of requests that can come in from the same, endpoint. And then from there, set up the timeout, the amount of requests, and what's going to happen next, like the error message, 404 error message that occurs, things like that. So a deeper look at the policy features. So there are quite a few. We have access control. You can control access based upon geography, based upon IP. There's a wide range of different things that you can enforce on your load balancers using WAF. We also have bot management capabilities. So it identifies whether requests are coming from a human or a machine. You can set up CAPTCHA. You can also block non-human suspicious requests. When it comes to protection rules, so we have many different protection rules like SQL injection protection, you know, cross-site scripting, PHP injection, things like that. You can also inspect traffic as it tries to access the server or as it leaves the server. And then, as I mentioned, you can set up rate limiting, which will provide protection against layer 7 DDoS attacks. We also have a Bastion service. So traditionally, you'd have to go in, you'd have to manage and maintain an additional jump box or additional compute service, and you'd have to pay for that service. You'd also have to manage that service. So with Bastion, it's going to be a fully managed OCI service that improves your security posture by providing secure access to private target hosts within your VCN. It helps improve security, eliminate costs, deployment, and then also the management pane of jump hosts that you may, spin up within your VCNs. All the access to the target host via Bastions is going to be time bound. So it provides restricted and time limited access to target resources that don't have public endpoints. The access is governed by OCI identity and access management policies. So those policies are going to be allow only policies, and they really are the fundamental security piece that was discussed in the first half that governs who can access what within your tenancy, within your environment in OCI. These bastions are essential and tenancies with stricter resource controls. As an example, you can use a bastion to access compute instances and compartments associated with the security zone, since instances in a security zone can't have public endpoints, right? That would be one security zone policy rule that you can enforce. And all of the administrative actions, like who, when, created, updated, deleted, the Bastion and session are going to be recorded in our OCI event and audit service. So it gives you that clear audit log of what's going on there as well. So next up, I'm going to jump into the OCI console and give a demonstration of CloudGuard. All right, you all should be able to see the OCI homepage. So when you first get logged into your account, this is going to be the main landing page of OCI. So all of our resources are going to be located up here on the navigation menu on the top left. And it seems like a majority of us have on the call have around less than 2 years of experience in the cloud. So I'll just give you a brief overview. So when you first get logged in, this is going to be the main homepage. All of your resources here are located at the top left. So you have things like our core services, we have compute, storage, networking. We also have Oracle database, and we have third-party databases as well, some open source options like Postgres, MySQL. Come down to identity and security. So this is where most of the tools and services that we talked about today are going to be located. You have your identity domains. This is where you access, your users, your groups. We have policies, compartments, federation. If you want to set up federation to a third-party identity provider, you can do that as well. We have our certificate service, web application firewall, vault service, Bastion, the audit section. So one thing to keep in mind is that every click that a user makes within your environment or every API call is going to be recorded within this audit log section. So anytime someone changes something, right, you can go to the logs, you can see everything outlined, every change that was made within your environment. So let's jump into CloudGuard. So I'll just click on CloudGuard here. So right off the bat, it gives us an overview with a security score rating, a risk score, and some security recommendations that are commonly seen throughout our environments. So we have some instances that are publicly accessible. This is creating problems. We have a VCN security list that allows traffic to restricted port problems. So again, this environment here is for demos and testing. So we're not really locking this down like a production environment. That's why you can see we have, a fair security score rating and there's a lot of problems that are occurring. But in your environment, you would essentially have this at a better score and you would have less problems because you would monitor this and you would go in and fix the problems as they occur. Right, but you can see the problems broken down in this donut chart here by severity level, critical, about 300, minor, low, medium. You can also view problems grouped by compartment, detector type, region, and resource type. User activity problems. So you can see user activity problems on the map, and you can drill in and click into these user activity problems. So you can see like 2 user activity events occurred in Salt Lake City, Utah. So we can click into this and expand upon this and drill in and see exactly what's going on, what problems have occurred from these regions. But how do we get to this point, right? So this is all coming from the targets that we set up and the detectors on those targets. So first up, let's take a look at the detectors. So we'll go into recipes on the left-hand side. And when you first come to CloudGuard in your environment, at the top of the page, you'll see a button that says Enable CloudGuard. Again, this tool is free and it's included with your subscription, so it's a good idea to take advantage of this service to just keep an eye on problems that have been generated. So Oracle is going to provide you with these Oracle managed detector recipes. Oracle managed, right? So we'll click into one of these. Let's go into our configuration detector, Oracle managed. So best practice is going to be to clone the Oracle managed recipe. So you just click clone at the top, we'll give it a name. So we'll call it clone configuration detector recipe, right? And then you just click clone. So I already have one cloned for the sake of the demonstration, but that is how you would create the clone. You just give it a name, choose the compartment you want to have this exist at. Typically, you'll want to place it at the root compartment. The root compartment again is like the highest level compartment in the tree. So you can see here at the root compartment, it's going to be accessible. And then if you want to apply it at the root level as a target, it will be available there. So you go ahead and you'll click clone, and we'll take a look at one of the clone recipes that I've created. So we have this Vision Corp configuration detector. So this is a clone from the Oracle managed um, detector recipe. And then from here, you can actually modify the rules. So let's say we want to change this rule here, and we know we have a NAT gateway, right? So we can click on this, we can disable this rule, we can enable this rule. You can also change the severity level. So we can go in and we can edit these rules, change the status, change the risk level here, critical, high, medium. You can also add conditionals. So you can say, if these resources are tagged with this particular tag, we're going to apply this rule. Or if it's in this VCN, right? The OCID is essentially a unique identifier. So we can say, all right, well, this VCN we know is not supposed to have a NAT gateway, but we want to be notified if a user creates one. Like we want that problem to be generated so we can keep an eye on that. You can go in and you can set the VCN OCID. You can do in or not in, and then you can just list the value here. So you could put the VCN OCID, and then from there, you're creating conditional groups, and you can do that based upon OCID or tag. So again, you take the Oracle managed recipe, you create a clone, and then you can modify the rules here in the rule set. So let's take a look at some of these rules, and these are what generates the problems within CloudGuard, right? And a lot of these are low risk levels, which can be disabled, right? Like VCN has local peering gateway. Let's say I know I'm going to have an LPG on my VCN, so I'm just going to go in and disable this rule. Right? So you can go in and you can make modifications here. But some of these are pertaining to users, security lists, gateways, and it looks like there's 5 pages of different rules. Vulnerability scanning, right? Scan host has open ports. That's going to create some problems. Scan host has vulnerabilities. They're not up to date with the latest patches or security updates. Object storage, pre-authenticated requests exists. Some pertaining to MySQL, right? System is publicly accessible. A lot pertaining to load balancing, computing, right? Instance has public IP. And that's why we give you that option for conditional groups, right? Because if you know one of your instances is going to have public IPs, then you can create that conditional list to exclude it. Some pertaining to IAM, Oracle database, more for object storage and block volumes, and even autonomous database. Right, so after you create the clone and configure these recipe rules to fit your particular environment, that's when you go in and you apply it to a target compartment. So I'll show you how to do that as well. Go back to the home page here. We'll go into configuration. And on the left-hand side, you can go in and set up a target. So we'll go ahead and create a target. We'll call it demo target. Give it an optional description if you want. And then you select your compartment, which would be the target. So again, if you want to apply this to everything within your environment, you would do it at the root level. If you want to apply it just to, a lower level compartment, let's say you have your compartments split up by environment. You have a development compartment, production compartment, and a testing compartment. You can set up different rule sets, different policy, like different recipe rule sets for each one of those, and then you can apply them accordingly. Right? It doesn't have to be like a one size fits all. You have that ability to customize the policies. So you'll go in, you'll select your compartment, and then from here you can go next, and you'll select your recipes. So that's what we just took a look at. So I think there's like 5 that are provided by Oracle, each pertaining to different things, right? Configuration, user activity, threats that are incoming, as an example. So we took a look at the configuration detector recipe. So that's what I'll select here. We also have recipes for container security and instance security. So you can optionally select those here as well. But from there, I'll just click next. And then from there, you can create that. So that's a walkthrough on how to, set up your targets, how to assign these detector recipes that you define to your particular compartments. So I've already have this set up, but it could take a few hours after you configure that for the information to start populating within the dashboard. And that's what's going to generate the security score, the risk score, and then you can view, the problems as well. So we'll go in, we'll take a look at the problems next. So the recommendations, these are going to be like top 10 recommendations that's pulling from the problems. So here, this ties into our example in the slides. Resolve public is, or bucket is public, excuse me, problem, and CloudGuard target. So we can click on this one, go in and view the problem. And you can see this is occurring multiple times. So it looks like we have multiple buckets that are public. But each time this occurs, we can see, the resource name. So we can see exactly what bucket is public. Does it need to be public? Are we sharing something publicly? Or is this something that is an issue and should be made private? So if it needs to be made private, we can click on the problem and it's going to give you a recommendation here, right? The recommendation, it's going to give you some general information, the bucket name. And then in this example here, we have a one-click remediation. So I can click remediate. What are we going to do? We're going to make the bucket private, and then you just click remediate here. So this is going to make that bucket private, and then that problem would be remediated. So that's the automatic or automated responder, but you can also go in manually. Like I can click on the bucket name, navigate to the bucket, and manually make it private. And then what you would do is come back to CloudGuard, you would mark it as resolved. Additionally, if you know this bucket is supposed to be public, you can go back into the detector rules, like the detector recipes, modify the rule there. You can add it to a conditional, right? You have your resource ID, you have your bucket name. So you can add this bucket to one of those conditional groups if you know it's supposed to be public. and then just dismiss it so the problem doesn't occur again. But if you don't go back into the detector rule set and modify it there, then like if I just dismiss the problem, then it would occur again, you know, as each new scan comes through. All right, so that's Oracle Cloud Guard. I'm going to hand it over to Borna. We have about 5 minutes left. Feel free to reach out to us if you have any questions pertaining to any of the services we talked about today. But I'm going to hand it over to Borna, who will take us through the closing, thoughts and statements and what's to come for day one and beyond.
Once again, awesome session. Thank you, Hannah and Brandon, for today's session. Really appreciate your time and help with this, with all of this, and hope it was a good learning experience for everyone. So, if you enjoyed this session and would like us to conduct personalized training sessions for your organization, please do email us at our personalized training email, and we will reach out to you. If you want us to conduct just a hands-on lab, we have the newly designed QuickShot Live Labs. Um, for a more expedited hands-on learning experience for specific cloud topics. Also under our Code Innovate program, we do co-develop a solution based on your use case as well, and as well, and also that just keep in mind that the personalized training program is an investment we make for our customers to help them grow and develop their OCI skills at no additional cost. And also, here we have a calendar to help show all the various offerings throughout the month that we'd have within our Day One and Beyond program. If you're interested in joining these other sessions, please pay a visit to our Day One and Beyond homepage and register. With that being said, thank you for today's session. I hope you have a good day.